Perfect. So the topic today was environmental impact modeling in ICT. What pitfalls should be avoided? So I'll try to make it as simple as possible, although I might go into technical details a bit in the middle of the presentation. If you do have any question, please just ask, and I can handle questions in French or English as you prefer. So the first part, on the first part, I want to first look to why should we assess the environmental impact, because I think the goal will be the red line all around my presentation. Then how can we measure right, and what are the tricks around the methodology, and last but not least, I will go through a use case, a study that we conducted with some partners last year, end of last year, that gave a white paper on product carbon footprints of manufacturer data compared to a parametric LCA and Resilio database. Before jumping into the subject, so who am I? I'm Amaël, I'm a Chief Executive Officer at Resilio. We're a Swiss company, member of the Swiss Sustainable IT Institute. And we do have a bunch of activities all around sustainable digitalization. And we focus especially on life cycle assessment for digital products and services. We do have a bit of academy, consulting, and a tech and database product that I will go through into the presentation. But let's talk about the subject now. Why should we assess? I guess my slide to those questions is always the same. Those are the planetary boundary. It is a small game that humankind is playing, and whose rule is very, very simple. We must stay within the green zone, and we must have no orange, neither red on the picture. And as you can see, we as of now are quite bad on playing this little game, which is quite a huge problem. So if I frame it another way, environmentally speaking, so if you look to the fundamental framework for our existence in life on this planet, we're environmentally speaking in a big, and when I mean big, I mean really, really big, something that you and I can probably not really frame in our small brains. We, environmentally speaking, are in a big mess. So this is what's shown on the previous slide. And there is no comment to have on this. No matter what could happen on the other side of the Atlantic, we do have a huge problem. If we recap where we stand currently, the infinite mindset that grows humankind for the past 200 of years since the Industrial Revolution do not hold with 9 billion people. It may with less than 1 billion, but as you have 9 billion people currently on Earth, it do not hold anymore. And then Houston, we have numerous and huge environmental problems, really, really huge. If we combine 1 and 2, we then have large problems and limited resources. So there is only one answer that an engineer as me can provide to such an equation. It's that we need efficiency. And more than efficiency, we need to avoid things going worse, and we will need as much forces, power, support, time, and energy we have. So we need to have everyone on board if we want to manage anything on our future. So this is the context, the environmental context we're in. Then framing it again another way. We want to we have this efficiency problem. We have a limited resource. They're not infinite. We have limited time, limited people, limited brain power. And we need to understand where to go, because the direction in which we're going currently is not the right one. And we need to avoid problem inflation. We want to go the right way. So we need efficiency. We need to know where to go at scale and everywhere, including in IT. And then you can see where is my slide going. This is the one goal of environmental assessment. So the reason why I do perform environmental assessment every day is not because I love numbers, but it's because we need to efficiently know where to go, including in ICT, including in mobility, energy, whatever sector of human activity, because roughly all sectors are dependent on our environmental framework. So this is the one goal. If we have anyone that is a bit suicidal in the team and that would prefer still going the wrong way, we do have also regulation. I just put some of them on this slides, and as you can see, it's a bit busy. We have more and more regulation coming in here. So here it's to focus for sustainability in ICT, for telecommunication, cloud provider, data centers, but also corporations. And the last large pillar was EU CSRD, starting from beginning of this year, where reports should be published. So if we step aside from the purely environmental problem and the stress it puts on humankind, we do have also regulation that now ask us to go directly into this environmental assessment games. What an introduction. Who am I to speak you this way, and what do I do? So quick advertisement on the next slide. Resilio is working specially around making life cycle assessments, so making environmental assessments easier. And we did develop, that was the core and the very first things that we did in company, an LCA software, which is specially tailored for ICT. And this is how we landed in this field. Providing compliance to standards, environmental data all included to make it as easy and as fast as possible, because we want people to go into action efficiently and in the good way. And we also did develop a database a year or so ago, but I will discuss it a bit later. So that's the why. We do need efficiently to go in the right direction from an environmental point of view. And there are many, many ways to fail this. And if we discuss on how to do it right, I think we should also discuss how to make it wrong. One point is this one. We want the good direction and an efficient path. So the two main pitfalls are going on the wrong direction and on the wrong path. And all the way from on an assessment point of view, we will have to avoid those pitfalls. First point will be the methodology. This is what you believe, what we all believe when we think about an assessment. Formula, schemes, mathematics, all about the methods, how we compute, how we make things right. This is the methodology. But we also have in environmental assessment an upstream problem, which is the upstream data. How much do one server pollute? How much do 1 gigabyte of data transferred on internet pollutes? All of this being upstream background data. And here also we need to avoid the both pitfalls. And last but not least, maybe the most important regarding our goal, which is to go into action, we need to take the right comparison, the right interpretation based on the comparison and interpretation we will have. So from an assessment point of view, what we want to do is having efficiency. So I would strongly advise using a tool, not only because I built one, but because I think we need not to try reinvent the wheel. We need efficiency. And using the standards, because with all the brain power we have, it's super useless to waste it repeating, recreating standards that already exist and can perform the work. And a second point is going into the good direction. So we need to be holistic. We need to have an holistic view, multi-criteria footprint. Carbon is not the only problem we have, unfortunately. And not everything can be seen through numbers. So having numbers and quantitative analysis is good, but having qualitative information is right also. And keeping this quote from one of our clients on a Green Eye podcast was, why do we measure? We measure to reduce. And this is the most important point. We want to go into action. So all the assessment must enable us to go this way. And I strongly advise using simplified life cycle assessments according to the ISO and EU standards on those topics for everything related to ICT and digital services. All the way long, the one point, and that will go through all my slides, the one point is to never forget, why are we here? We need efficient understanding or where to invest our limited power, energy, and efforts. So really need to have this in mind through any assessment methodological or consideration or project. Now, if we go into assessment approaches, going a bit more into the details and technical details, we can have approaches and we can have very various approaches. Some that would go into geography scope, some focusing on companies, organizations, on project, or even on services. Those are different approaches that can be cross and that can be combined with various ways to attribute responsibility, which is the one we know the most, or to check for consequences. I'll come back to this point a bit later. And with those two dimensions, we can even change the precision and accuracy we want to have. Because all the topics we will face, all the use cases we'll face when we want to provide one assessment are different. Different needs ask for different approaches. But in all cases, never forget the aim. First, we need to avoid the problems. So reporting is good, but avoiding the problems is better. And then we need to enable action. So no matter the approach you want to take, no matter your use case, those two key points are the best. We need to avoid problem before they happen, and we need to enable corrective actions. So all of this is a bit abstract. So going through one first example. EPFL is a research center, which is kind of the University of Louvain or whatever large university based in Switzerland, in French-speaking part in Lausanne. They made a task force that published a 30 or so page long report on environmental footprint of digital activities in the school. It asked for urgent action, and it was kind of the scientific way. So it was published in the school journal review. It was EV, it was in VM precision with a detailed scope that was the school. That's okay, as long as it support action, and it did. It was the format we needed in the school to make things start. So that would happen, a report and recommendation, which is not something we can replicate in all cases. So taking another opposite example, Alice is a tool, so it is a web app, no report any longer, no recommendation any longer. This is a small app that can be used within Publicis Group. Publicis is a large advertising French company. It is a proprietary software that they develop internally that help assess the impact of an advertising campaign for the project manager. So here we are again in working before the problem happened, when the project manager can really take action using the tool and going in the right direction. So we keep this model easy. We make the model as simple as possible with this one objective to enable the creative people, the product manager, to reduce their footprint. No matter if you want to make a report with high precision or a draft, or if you want to have a software or whatever Excel spreadsheet. The one point of the assessment is to go in the right direction and efficiently. Before going to the rest of my presentation, I just want to come back on this point of precision and accuracy. I extracted this morning those tables from IPCC website. IPCC is the International Panel on Climate Change, which is roughly the best scientific body we have on Earth talking about climate change. And you have in pink on the slide the percent of uncertainty on the most important greenhouse gases. And if you just look to the numbers, the smallest error bar is roughly 9%, and the highest one is roughly 50%. This is the best of science on Earth, talking about environmental assessment for the mature impact indicator, which is global warming potential, GWP, global warming potential to 100 of year, which is the way we compute with those kilograms of CO2 equivalent. So when we look to precision and accuracy from an environmental assessment perspective, never forget that the numbers are wrong no matter what you do, because the science behind is far from what we would expect, and the error bars are just insane, just insane. But what is important in precision and accuracy is getting people to move, getting people to act in the right direction. So making no mistakes when they want to go into action. Now let's go into the great ways to fail. If we recap, the first way is to go into the wrong direction, or have a too short-sighted vision, focusing only to one problem, or just going into increasing problems. The second way to fail is, of course, fault precision. What we look is not for the numbers behind the comma, it's for the decision we make, for the action we take. This is the only thing that's super important behind environmental assessment. Getting lost in the number this way is also a good way to postpone action, which is the opposite of what we do. And another point is having comparisons on things that can be. I will come back to this on the next slides. But even worse, making a decision based on biased information. So no matter the environmental assessment you do, the approach you take, and I will go through a lot of details after, no matter this one, you just need to focus on things that are really, really important, the action you will take with the information you provide. To understand this concept, I will guide you through a small example on inconsistency. What is inconsistency and how it hides into the details? So let's say that today I'm a buyer, I'm an IT buyer, and I want to have the best product for my company. I need to buy between two laptops. And as I'm a good and responsible person, I want to buy the less harmful to the environment, which is another way to say that I want to reduce the harm I will cause, because anyway, I will cause harm building a laptop. So I just want to compare brand A and brand B, and I have those price tag, carbon price tag, which are kilograms of CO2 equivalent. So easy answer, I just need to pick the smallest between both tags, which is of course completely wrong. Why is that? First point, because as I said, we want to avoid the short-sighted vision. So as for costs, we want to consider the full life cycle. We will have costs around for all the life cycle long. Same for environmental footprint. We will have footprint all the life cycle long. So we need to consider both of them. If we want to have a good view, we need to consider the variation between the products that may be, in this laptop case, the lifetime and repairability. So what we want to do and what we need to do in this specific case is to sum the costs and sum the environmental costs. Both work exactly the same. And then, as would work total cost of ownership, we want to divide it by 1 year of usage and dividing by the lifetime. Fixing, so my example, I want to compare product A and product B over 1 year or over a given period of time. And then the rest is very easy. I just need to divide, but nope. Second mistake, which is all about inconsistency. Now we have laptop A and laptop B information from provider A and provider B. I have those price tag. One is 120, one is 167. Easy to guess who pollutes more. Yes, but we can have inconsistency in background methodology. So one of the two assessments may have included more than the other. We're not sure that both of them include the same things. One may include the manufacturing of the screen and the manufacturing of the CPU, the processor, but maybe the other will not, or only partially include them, which make a bias in your result. You need to compare only things that could be compared. This is a bias in methods that we want to avoid, because it would lead us to go into the wrong direction, which is the opposite of what we want to do. Second inconsistency could be on data. Same assessment for laptop A, laptop B, assuming we have the same methodology. Then the background database they will use to know how much do one component pollute could be different. At the lowest level, when you make such an assessment, you need someone that tells you that 1 gram or 1 kilogram of a gas that you're using to manufacture your laptop is polluting X kilograms of CO2 equivalent. You need to move from the chemicals onto the CO2 world. And those information comes from IPCC, the short table I showed before. And IPCC knowledge evolves over time. So if you take report 4 on one side, report 5 on the other side, you have two different values. And you can, as you can guess, if you have different values at the very bottom of your assessment, the data at the outcoming of your assessment will be biased too. So variation in background data that are behind those assessments, the data that everyone relied on, which are the scientific data, if you want to call them this way, will introduce or may introduce a bias in your information if you forget to consider this inconsistency. And now, if you combine one of them and I ask you this simple question, who pollutes more? As you can guess, it started to be very much difficult to go which one is the right direction. Not forgetting, we want to go into action. We want to reduce the harm we cause. We want to pick the right one. It's super hard to trust the number if they're not consistent between themselves. So if I want to really fix my problem in this buying case, I will definitely need to compare consistent footprint for both information over 1 year of usage. So something that could have seemed very tricky if we do not look into the details of it, and I can understand this was a bit technical, but if we don't look into the details, we will end up going the wrong way and maybe in an inefficient way, which is the opposite of why we invested time in assessing the footprint. And now, when we speak about inconsistent data, the question you will ask is where to find a consistent source. And unfortunately, I don't have answer to provide right now because that's another part of my slides. But usually, back and to conclude on this small example of buying equipment, usually the longer the lifespan, the higher the repairability index. Repairability index has been introduced in France and is used on European market more and more widely. You also have labels like TCO development that or EPIT that produce labels on and repairability information on those materials. Usually, it's sufficient to compare because what you want is to take the right action. So in this case, we don't need all the precision. We don't need all the numbers. We may only need one single index to make a right choice. So back to our topic. We need to efficiently understand where to go at scales and including in IT. And this is the goal. This is the reason why we perform environmental assessment. Considering this, inconsistency is one of the most important risks you have to go the wrong way. Unfortunately, it's not the only one. I mentioned a bunch of them, but that's really a large one, which I want to insist on because few people are aware of it. It is really widespread in my view, cause a lot of troubles. Then, we spoke about how to fail, now how to make it right. Which methods can we use as practitioner to assess the environmental footprint of our product, services, company, or geography, and how we can frame those methods so that the result lead us on the right way. Usually, assessing asset footprint is a combination of background environmental data. I was just talking a bit before on it, And modeling. The background data is how much one server pollutes. It's usually stored in a table, an Excel spreadsheet, a database provided by a third party. It's very rare that you would have those information yourself. This is kind of background. And then is the modeling. And the modeling is all the schemes, the mathematical formula that you could have that says that for making a laptop here, the laptop system, you need a bit of energy, a processor, a screen, and you will exclude the battery because you don't have data on it. So two pieces, data on one side, modeling on the other. I will jump in both of them, starting by methodology. So here is the technical part of the discussion. Going into the methodology, we can classify environmental assessment methodology according to the scope and the perspective they take, plus the way the things they consider. So the scope could be either restricted to one environmental dimension, one environmental problem, a specific life cycle scope, specific life cycle step, or it could be holistic. Holistic meaning multi-criteria. We try to open our eyes, widen our vision to consider the full life cycle and multi-criteria approach. One example of restricted is the GHG protocol, as the name suggests, focusing only on greenhouse gases emission. And another one is LCA, which is life cycle assessment, as the name suggests, use the full life cycle and is a multi-criteria approach. Second dimension to classify is consequential versus attributional. So this one is a bit hard to understand. Consequential is action-based. So the question you want to answer is, if I change something in the system, which pollution output will change? And the opposite is the attributional, which is like accountancy, whose objective is to share responsibility. So you try to put the pollution burden on various stakeholders or various life cycle steps or various domain of a service to understand where does it comes from, but without this action-based perspective. An action-based methodology is environmental impact assessment. This is the study that is performed when you want to build a new building somewhere in Europe or a new industry, a new factory. You will look at what is before on the location and what will be after when you add. So action-based, when you have this consequence of having this building built. The LCA, again, LCA attributional, LCA-A, so attributional LCA, which is the most commonly used, probably the only one you ever seen, is attributional. You want to know who is responsible of what, so you will split the overall pollution, X for the data transfer, X for the data center, X for the end user. But you're not really that much, you're more in the snapshot perspective than in the consequential approach. And moving to the last, which is very easy to understand, you can have it on a project, product, organization, or a location. I put it here in a bullet point. Here is exactly the same with kind of a matrix. Two by two matrix makes consulting work for tens of years. So here you have few examples. I could put much more, but you have main dimension, attributional, differential, and restricted holistic. Focusing on one of the most important in the ICT domain, we have carbon footprint on one side, life cycle analysis on the other. GHG protocol is mainly treated and at the beginning was designed for states and countries. It is single criteria, has no systematic critical reviews, and often has regulatory local complements. Life cycle analysis treats products and services. So as you can see, every methodology has a different objective. It is multi-criteria and has regular critical review. And in the EU, we have the product environmental footprint, which is a bunch of standards to make it right. How does all of this look like? A carbon footprint look often like a pie chart. So we want to know who is responsible for which percent of the pollution and drive a conclusion. The life cycle analysis will do exactly the same, but with not only one, but many impact factors, impact dimensions. So you will have greenhouse gases emission, but also rare elements, water, or ionizing radiation if you look about nuclear power. And this is my personal take on it. If we want to go the right way, we need to pick the right methodology because we could be too short-sighted. Although I must admit that facing reality in some cases is not really easy, and we may have assessment that do not provide easy answer to the question how to reduce our impacts. This is my recommendation if you have any methodology to take using the product environmental footprint and the product category rules system. Product environmental footprint is the EU recommendation for life cycle assessment. So you have an ISO standard you can base on, you have a recommendation from the EU you can base your contract on, and you have product category rules. Product category rules are a complement to the standards that enables you to have the specific rules for a book, for a car, for a screen, for a data center, or whatever things you want to assess. So the product category rule, as the name suggests, gives you the rules for one product category. And we have a bunch of them. Some of them develop in France, some develop in other places around digital services in ICT, so please use them. People spend time on making good standards that provide you good answer, the most performant answer that try to make it efficient and lead you on the right way. Do not hesitate to use it or ask your supplier or clients to use those standards. We talked about methodology, now jumping into background data. I must have one disclaimer. I'm very much convinced that inconsistency in data is one of the worst flaws in the environmental assessment, as you may have understood from my previous parts. So I might be biased on this. And second bias, Resilio develop and maintain a partly open database for environmental footprint data on ICT, whose name is Resilio database. So that you know, I'm not perfectly independent on this discussion. But let's go to the different sources of data you may use. The first one is supplier data. Usually suppliers' data are product carbon footprint. They are provided by the manufacturer. Those are those nice PDF, as you have a snapshot here, released usually by product or family of product, published once when the product is released, sometimes audited, and they are for almost all of them carbon only with a very poor methodology note. So you have roughly no information on how did they get to this here 235 kilograms of CO2 equivalent. These are the PCF, the manufacturer data. Not most, but a lot of them comes from PAIA. PAIA stands from Product Attributes to Impact Algorithm. It's a project started by an MIT lab and an EPFL spin-off. So Swiss guys were there, founded by manufacturers. The manufacturer, they work together to have this way to give you those PCF. They stand on MIT research, or they should stand on. And this is what we can describe as a kind of parametric life cycle assessment. I will come back to this parametric used by the manufacturer to disclose you those information. Understanding what means parametric, you have it here. So you will take product attributes. What are the technical specs of the product? Then you will make an inventory out of it, a build of material out of it. So I have one screen, so it means that I have that much of aluminium, that much of plastic, that much of screen, and you will list all your inventory. And then from this inventory, you will have this environmental assessment and go to the final result, which is that much of energy, that much kilograms of CO2, that much usage of water, etc., etc. So this picture is out of PAIA description. It is a kind of what we call parametric LCA. Parametric because it is an LCA that we perform, but we use parameters, product attributes here, which unfortunately is completely opaque. So if you want to learn one thing about PAIA, it is widely used, it should be right, but providing consistent results that we cannot explain because it's perfectly opaque, which is a point. In another parametric LCA, this is the disclaimer, Resilio database provides, Resilio provide a database, Resilio-DB, where data is represented by a model, a bit like in Paya, and data is generated upon call. So we do not have any row in a table any longer, but we generate data every time you ask us for. This is one interest, is that we can have much more updates, roughly one every 5 weeks, and thanks to reduced data production and maintenance costs. And we can fill the gaps because manufacturer data is not fully available for all products. So when it is not, we can provide information, and it is fully automated, providing advanced feature for documentation, version management, or auditing. How does it look like? Here is an example took from yesterday from db.resilio.tech. Feel free to try it online. I tried one virtual machine from AWS in Belgium. I also tried a Samsung Galaxy X Cover, which is a smartphone used in China, and I even tried a Microsoft Surface laptop used here in Switzerland. So you can browse thousands, tens of thousands of reference online. Generic data, parametric data here, so it is not the manufacturer data, whose short name is PCF, but it is made by a third party providing consistency. And last but not least, the mostly used data sources are a generic database. As the name suggests, those are fixed data points. The footprint of one server is blah, 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 for a generic or average model of one category of device. What we mean by that is that you will find in Negaoctave, for instance, you will find one average gaming laptop, one average office desktop, one average multifunction printer. Those are the kind of generic data point that you can find. And as the name suggests, they are generic, which from a precision or accuracy or automation point of view may cause a bit of difficulties. The most widely used databases are generalist database, Ecoinvent and Base Empreinte in Europe, or one of the leaders. And in ICT-focused database, Resilio database provides you a free survival kit that's available on our website. And Negaoctave used to provide such kind of data, but has been discontinued due to partly to high maintenance costs. So data are now going to just be older and older every day. All right. We jump into the how to, why do we do it, how to do it right, which methodology and data we can use. Last, I want to share with you a use case that was how those data perform, one comparing to the other. So we have this inconsistency problem in mind. We can use various type of data, and in the end, what we want to do is going in the right direction. Which data source should we use? So what I will present right after is the results of a white paper produced by Resilio Lab, our R&D department, and our partner Aguaro, which is a software provider for environmental footprinting in ICT. And we assess differences between Resilio database and product carbon footprint for roughly 20 laptops, and we are going now to hundreds and thousands to repeat this assessment at scale. The key lessons on how one work compared to the other is that there is no systematic bias. I cannot tell you that the manufacturer generally generally underestimates their footprint. They are not lying. There is no systematic bias that we can see. The impacts are on the same ranges. So whether you use one or the other source, the absolute value look like to be roughly the same. But don't forget, devil is in the details. The PCF data, of course, show signs of inconsistency, as we could expect. And their methodologies are not disclosed. So this makes, unfortunately, almost impossible to understand the results on the manufacturer side, although we can have a huge precision and documentation on Resilio DB side. And as Resilio DB is far from perfect, it may be less accurate because we're not manufacturer, but it shows consistency and transparency. So looking back to our objective, going efficiently in the right direction, it looked like that parametric LCA is a good compromise as it provides roughly the same range of value, no large mistake, no systematic bias, but it comes with consistency, widest catalog of data, and transparency. To understand how this is possible, we need to understand that Resilio database is a mix of models. So here you have a snapshot of the models that are included. This is what we can assess, and that models combine one to the other. So all the models are built on the lower layers, which means that if we change only one layer, everything will be updated every time. So we have a much better consistency. And as we used parameters, consistency is a core property. So we use the parameters, we combine the model between them, which means that whether it is a Lenovo or a Microsoft or a Dell laptop, when it is assessed through a parametric LCA, Resilio DB or another, it will have a consistency property because of the parametric LCA, which is very important in our going into the good direction objective. Only the meaningful differences are assessed in Resilio database, which means that we do not go for over precision and we try to balance precision and usage, having a wide catalog, even if we need to sacrifice a bit of precision, having in mind what precision may mean. I do have data to substantiate my claims. As you can see here, in blue Dell datasheet, in green HP datasheet, and in gray Resilio DB data points. As you can see, there is no rule of over or underestimation. All are in the same range, and the deviation is, at the end of the day, quite low. Also, when I claim that PCF data are inconsistent, I can demonstrate it. Here is a quick snapshot of the screens information. So we only extracted the screens from Dell and HP. Screens which do have exactly the same screen size. So every scientific evidence we have up to date, even looking back over time, suggests that one screen with the same technology should have roughly the same footprint when it has the same size. So to get the footprint of a screen, we roughly need the surface the size, and that's it. Here we have a 1:3 ratio for the same size. Nothing to explain it, and unfortunately, no methodological notice to get it right, to go into the details and the exploration. So the outcome of the white paper, and I can only encourage you to download it. It will be on the slides, and I will share it with the ISIT. The only outcome we have is that they provide inconsistent data that we cannot explain because we don't have transparent methodology to work on, which is a point when we want to go efficiently into the good direction. And some conclusion, and I'm reaching the last slides, some conclusion on why PCF fails. Why are they wrong? Those are mine, hypotheses of mine. We believe that the ICT companies, the manufacturer, invest in disclosure as much as any other, which is roughly zero. And they also depend on a large value chain, which makes things even more complicated. So there is no miracles. The manufacturers face exactly the same problems that any person working in sustainability in any industry. They work with all the Excel spreadsheet, all the value interns because we don't want to pay full-time jobs. Colleagues we have other things to do on their times, no objective on sustainability. So in the end, we cannot make miracles. Grab a gene, garbage out. And that's probably what explains the most, is that there is an organizational issue on how we made those information, because they should be more accurate. They should, BCF should be more accurate than the parametric LCA, but currently this is not the case. And you can add up also that in ICT, and this is ICT specific, the data do not leave. It is stick for the PCF, it is stick in the PDF forever, while the knowledge in ICT is very fast evolving. So having no API, no distribution center, but just PDF with data that you copy paste within is probably a bit archaic and unadapted if we really want to have disclosure over the full value chain. Well, I'm reaching the end of the time, so it's time to wrap up. We discuss assessment. How and why should we assess? I guess we should assess to optimize our efforts. We are in an environmental mess. We have limited resources. We need to optimize our efforts and avoid making things worse. Second, there are pitfalls along the way. Two main ones being inconsistency and overinvestment in precision, for instance, that would make you waste your time. Pitfalls that we want to avoid. Third, unfortunately, there is no magic methodology. We discussed plenty of methodology, all of them fitting more or less various use cases, but there is no one single answer. And last, on those data parts, the manufacturer data are, as of now, inconsistent. And unfortunately, I'm not sure it will improve in 2025. So that's one thing. And the second point is that generic data are generic. So be ensured that if you use them, you can cover the use case you're working with. So the conclusion on this data part is that parametric LCA may be a good compromise. Resilio-DB is one. Boa Vista API is another source. You can find plenty of them, or some of them. So in my opinion, yes, parametric LCA is a good compromise on this data part. I hope I covered the topic in an interesting way. I reached the end of the time and the end of my slides. So thank you very much for your listening. And if you have any questions, please feel free, both in English or in French.